Today we are going to learn about chemical reactions and chemical equations. Before we start chemical reactions, let's consider a few examples. If milk is left overnight in the room temperature, then what happens? It converts into curd. Once the milk is converted into curd, can we get the milk back? It is not possible. Similarly, when we cook food, once we cook it, after that we cannot get the raw vegetables or raw cooking materials back. Also, when we eat food, food is digested inside our body. To give us carbon dioxide, water and energy. And once it is formed, we cannot get the food back. So in all these examples that we are seeing, in all that, the one thing which changes is the identity of the starting material. Similarly, let's take few other activities and see what happens. When you have a magnesium ribbon and you burn it, you will see that it burns with a bright white light, and after some time you see some white color substance getting formed. It's a white color powder. Now initially magnesium was a metal, a shiny metal, and afterwards we are getting one white color powder. This white color powder is nothing but magnesium oxide. Now we started with magnesium, and how did we get this magnesium oxide? Are they both same? Can we get the magnesium back from magnesium oxide? No, it is not possible. Let's see another example in which you take zinc in a conical flask and add dilute hydrochloric acid to it. Dilute hydrochloric acid. Once you add the acid to zinc, you will see some bubbles are coming out. Bubbles of gas which is coming out. Now what is this gas which is coming out of it? We never had a gas in the beginning. We had a solid substance which is zinc, and we had a liquid which is dilute hydrochloric acid. Now from where did the gas come out, and what is the gas? The gas is hydrogen. So after considering all these examples, we can make out that there is some kind of change which is taking place when we add these substances. Like when we add zinc and hydrochloric acid, some reaction is taking place due to which hydrogen gas is formed. Similarly, when you are burning magnesium in the presence of oxygen, then magnesium oxide is getting formed. So some kind of reaction is taking place. Some kind of change is taking place. What is this change? Let's first characterize the change which is taking place. What are the characteristics of these changes that we have seen? First thing, new substances are formed. Also, these reactions cannot be reversed back. These are irreversible. And we have also observed that the chemical composition of the substance changes. chemical composition also changes. Now, any change which has all these characteristics can be called as a chemical change. This is called as a chemical change. Now, how do we represent these chemical changes? There must be a proper way to do it. Let's see how can we represent the chemical changes. First example that we have taken magnesium plus heat. Then we got magnesium oxide. When we are heating magnesium, we are heating in the presence of air, and in the air magnesium reacts with the oxygen. So we can say that magnesium, when heated in the presence of air, then it reacts with oxygen to give you magnesium oxide. Now this kind of representation of a chemical change is called as Ward equation. Now this Ward equation is nothing but basically the chemical equation. So we can also say that the chemical changes can be represented by chemical equations. So what can we say? We can say chemical changes can be represented by chemical equations. Alright, now there are two types of chemical equations we can write. First one I have already shown you on the board, that is the Ward equation, and the second one is the skeletal equation. Now what is this skeletal equation? So let's see how can we write the skeletal equation for a chemical change. So first we write the Ward equation: magnesium plus oxygen giving you magnesium oxide. Now over here I would like to mention few things about the chemical equation before we go for the skeletal equation. On the left hand side, this part is known as reactant, and this part is known as product. Now you can see that the reactant and the product, they are separated by this sign. So always in any chemical equation, the reactants and the products should be separated by an arrow mark which points towards the product. So which means that the reactants are the starting materials. You begin with the reactants, and after the chemical equation, after the chemical reaction, the new substance which is formed is the product. That is why the arrow mark of this chemical equation points towards the product. Now you will have more than one number of reactants and sometimes more than one number of products. So in that case we add a positive plus sign. We add a plus sign between the reactants if you have more than one number of reactants. Similarly, over here in this example we have only one product, but in various examples you will see that more than one products are there, so you can add, write a plus and then you can write the other product, whatever is formed along with it. Alright, so these are some general representation notations to write the chemical equations. We can use it in the word equation as well as in the skeletal equation. Now in the word equation, we have the names of the substances which are reacting. We write the complete names in the form of words. That is why it is called a word equation. Now from these words, when we write the molecular formulae and the symbols of the elements, then that becomes the skeletal equation. Now what can be the skeletal equation for this one? We have magnesium. First thing, we have magnesium. Now what is the symbol of magnesium? It is Mg. Mg is the symbol of magnesium. Plus we will write what is the symbol of oxygen? It is O, and generally oxygen is a diatomic substance, so O2 is a proper symbol of oxygen molecule. We cannot write oxygen atom over here, we can write oxygen molecule. Then we separate them with an arrow mark and then we get magnesium oxide. Now what is the formula of magnesium oxide? MgO. Now this is a skeletal equation for the following. Alright, so this is how we are going to represent various chemical changes. Now is this it? Is this the correct equation that we are writing? What is missing over here? Let's see how the equation can be corrected. See, over here we have one magnesium on the reactant side and one magnesium on the product side. But we have two oxygen atoms on the reactant side but only one oxygen atom on the product side. And also we have a law which is called law of conservation of mass, according to which the total mass of the reactant must be equal to the total mass of the products, which means the number of atoms of a particular element present on the reactant side must be equal to product side. So if we have two atoms of oxygen on the reactant side, then we must have two atoms of oxygen on the product side as well. So to get that, to have both the sides equal in number of atoms, we need to balance the chemical equation.